Let's talk about intermediate value theorem. It helps us to locate a zero of a polynomial function, or we can say x-intercept of a polynomial graph in between two numbers, or in between two different numbers of a domain, of the polynomial function. So here let us take f to be a polynomial function, and let us suppose a and b are two numbers such that their functional values are of opposite sign. Then there will be a number c such that a is less than or c is less than b. That means c lies in between a and b, and f of c equals to 0. That means c is a x-intercept of the given graph of the polynomial, or root of the polynomial equation. Now how to interpret this thing in graph would be, let us consider this polynomial. Then you can clearly see that if you suppose this point a, then f of a is definitely a negative number. This f of a is negative number, and this point, suppose this is b, then f of b is certainly a positive number. F of a is negative and f of b is positive. Then there is a point, this point, such that at this point, let's suppose this is c1, f of c is 0. That means c1 is a x-intercept. Similarly, let's choose another point somewhere here. Let's suppose this is a1, then this is positive, f of a1 is positive. Okay, and carefully you can go for this one, this point. Then this is, let's suppose, b1, then f of b1 is negative. Then there will always be a point where the continuous graph will intersect the x-intercept, and let's suppose this is c1, then f of c1 is also equals to 0. Let us use intermediate value theorem to figure out 0 or x-intercept of this polynomial function in between x equals to -4 and x equals to -2. We want to first check the functional values at x equals to -4 and x equals to -2. Let's do that. F of -4 is simply -4 cube minus 9 times -4. So that is 64, -64, and minus plus, that's 36. So since 64 is a bigger number, 36 is smaller, and it has negative sign, so this would be negative. Okay. And similarly, f of -4, -2 would be -2 whole cube minus 9 times -2 equals 2 cube, that's -8, that is plus 9 to 18. So here you can easily see that 18 is a bigger number, -8 is a smaller number. That means 8 is a smaller number, so this is greater than 0. So f of 4 and f of -2, f of -4 and f of -2, they have opposite signs. So there is a point. So by intermediate value theorem, there is a point c such that -4 is less than c is less than -2, for which f of c equals to 0. So f of c means f of c is c cube minus 9c. Okay, so I'm plugging this c in here, equals 0. Let's solve this equation and find the values of c. So c square minus 9 equals 0. Then we would have c equals to 0, or c square minus 9 equals to 0. Thus this is c equals to plus or minus 3. Okay, thus we have c equals to 0, c equals to -3 and +3. Thus we get 3 different x-intercepts or zeros of this polynomial. We will try to see which among these 3 will lie in between -4 and -2. It's of course that -3 will lie in between -4 and -2. So this is the correct answer for our question, and these two are not the correct answers for our question. So that's how we find the x-intercept.